All right, thank you so much for tuning into this lesson. Today's lesson is on computation of an average called the median. What is median? The median of a data is the middle number when data has been arranged in an increasing or in a decreasing order. So if the data is arranged in a systematic order, increasingly or decreasingly, then the median, and get the middle number or the middle observation, then that's what we refer to as median. Now, for odd numbers, the position of a middle number is obtained by n plus 1 over 2. Ith position. This word ith position is important. What we are saying here is that median is a positional average. What we are saying, we say that median is a positional average. This is A. Median is a positional average. What we are simply saying is that it tells you the position of a specific variable in that series. So that if it is an odd number, if the number of observations are odd, then the middle value will be given by n plus 1 over 2 ith position. A simple illustration is this. You have got five letters: A, B, C, D, and E. The question is, what is the middle position of these five letters? What is the middle position? Obviously, the middle position is 3. But how do you get that mathematically? We are saying because these are the number of observations are odd numbers. These are odd numbers. 1, 2, 3, 4, 5. 5 is an odd number. Then the middle value of these 5 letters would be 5 plus 1 over 2, which is 6 over 3. So it occupies the third position. The third position. So C occupies the third position. So median is not 3, but we're just saying that the third position is what that observation will entail as the median. And so we are saying C is the third position, and therefore it is the median of these 5 letters. If the number of observations is even, if the number of observations in that data set is even, then the median will be found by getting the average of 2 middle numbers. If you have got even numbers, then the median will always take 2 observations, the middle 2 observations. And that's what we are saying, that the median will be given by n over 2 ith position plus n plus 2 over 2 ith position divided by 2. And we can look at that as we can look at that, for example, if you have got letters, you have got A, B, C, D, E, and F. Ideally, you're supposed to arrange this data in a systematic way. The first thing is that you must arrange it in ascending or in a descending manner, so that after that now you compute. So what we are simply saying here is that what is the number of observations? 1, 2, 3, 4, 5, 6. So the number of observation here is an even number. 6 is an even number. because 6 is an even number, the median of these 6 observations will be the 2 middle observations, as you're seeing, 1, 2 on the left side, 1, 2 on the right side. So the remaining values here, these two values here, these are the ones that are at the center. So how do we get this mathematically? We are simply saying it is n over 2 ith position. So you get 6 over 2, which is third, 3. So it will be the third position, plus 6 plus 2 over 2, which is 6, plus 2, which is 8, divided by 2 is 4. So you have got the third position, the third plus the fourth position. Now, if you get the third and the fourth position, you go back to the observations. So what is the third position? The third position is 1, 2, 3 equals to C. And then what is the fourth position? It is D. So if you are to calculate the median, it will be C plus D divided by 2. I think basically that is how we compute basic data, data that is not grouped, if I would say so. And so we're also saying that for large data in a frequency table, the median will be given by, again, we have said it is either summation of f over 2 or summation of f plus 2 over 2, as we have just said, if it is large data. Let's now move ahead to compute using examples. This size of n plus 1 over 2. For example, can you find the median of the following? The following data relates to the number of patients examined per hour in a hospital. The number of patients examined here, you're seeing it's 10, 12, 15, 20, 13, 24, 17, and 18. Calculate the median. So what are we supposed to do here? As I've said earlier, first you arrange these numbers or these observations in an ascending or in a descending order. So given this number, this is what we have done. We have arranged these values in an ascending order. The least value is 10. As you can see here, the least value is 10, and the highest value there is 24. So given these observations, you can see here that the median will be the size of n over plus 1 over 2 ith item. So it will be how many observations? 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 is 9. 9 over 2 will be the position that lies at the center for this specific data. So here we are saying that the median will be the size of 4.5 ith item. Now, in this data here, as you can see, the values here, the values or the observations are actually having an even number. So the median will take care of these two observations, observation 15 and observation 17. So what will be the median? I guess it will be 15 plus 17 plus 2, and you get that to be 16. That is how we calculate the median of a value. Now, you have been given another example here. The following figures represent the number of books in statistics issued at a county in a library on 11 different days. So you are issuing out borrowed books, and somebody asks you to calculate the median. As I've said, the first thing is you arrange the data in an ascending or in a descending manner. Then the number of items is 11. So what will be the median? The median value, it will be the size of n plus 1 over 2, ith item. So the median number of books borrowed will be 11 plus 1, which is 13, divided by 2. So that's what we say. 11 plus 1, which is 12. And so the median will be the 6th item or the 6th book. And if you look at this, the 6th book is, as you can see here, the 6th book is 1, 2, 3, 4, 5, and this will be the 6th book. That will be the 6th book. And so the 6th book here will be number 98. As you can see, there were 98 books that were borrowed. There were 98 books per day. We can stop there for a while as we move on. Right, thank you. We moving on after that short break. The question that I want us to think about is what I've just asked here. If a data set has an even number of observations, the median A cannot be determined. B is the average value of the two middle items or observations. 3 must be equal to the mean. D is the average value of the two middle items when all items are arranged in a descending order. What is your answer? Is it A, B, C, or D? Very well, I'm sure you have found it. The first answer is wrong. So this is wrong. Now, the average of the value of two middle values, this is also not wrong. Why? Because we are saying it must be precise. It must be, the data must have been arranged in an ascending or in a descending order. They must be equal to the mean. Again, we are also saying this is not true. And the answer that we are looking for is the average of the two middle observations when all the observations or items have been arranged in a descending, and in our division we had said a descending or ascending order. That's good food for thought. The second question is, a distribution of 6 scores has a median of 21. A distribution of 6 scores has a median of 21. If the highest score increases 3 points, the median will become so a distribution has a distribution of 6 scores has a median of 21. The middle value is 21. So the highest score has 3 points on top. What will be the median? Think about it. So in answering this, let me use the examples that we have. You have a distribution of 6. Let me assume that this is where my data 1, 2, 3, 4, 5, 6. I'm just using this set of data from here to here. So a distribution has 6 scores and the median is 21. So assuming that these values, please, we are assuming it was a number, maybe 19, 20, 15, until you get the median to be 21. Now the last value here has increased by 3. Will it change the position of the middle value? There you have it. So it means that the median here will not change, and so this is the true value. Now we want to start computing these values. In case of discrete data, now let me make some clarity here, or clarification here, that we have got basically two types of data sets. One is called continuous data, the other one is called discrete. Now if you have selling things like, say, cows, goats, pairs of shoes, tables, you cannot sell them in halves. For example, you can't say we have 2.5 people, or 3.5 cows, or 3.5 tables. So such data is what we call discrete data. It has got the data assumes a whole number. Theoretically, it assumes a whole number. But for a continuous data set, then the data assumes any value within that given range. So any value could be 0.2, 0.4, 0.9, and the like. Now you have this information here. In case of discrete series, the position of the median is n plus 2 over 2. Ith item can be located through cumulative frequency. The steps involved in calculating the median are as follows. First, you arrange the data in an ascending or in a descending order. Number 2, find out, or you calculate the cumulative frequency. Number 3, what is the position that the middle value occupies? What's the ith position? So it will be n plus 1 over 2. And then number 4, look at the cumulative frequency and then establish where that middle value falls, and then relate that with your data. We're going to look at that. Now we want to calculate the median of this data. For example, this is data. Calculate the median from the following data. You have marks by students, then you have the number of students. So you can see here, this data needs first to do what? Needs to be arranged. This is the trick around this exam. So the first thing here, you have to arrange this data. Just rub it so that you arrange this data properly. So the list value is 5, so it's 5, 15, 25, 35, 45, and 55. That's why you have seen that after this data has been arranged, then we get the least to the greatest. That is now in ascending order. Then you get the corresponding frequency, and then you get what we call the cumulative frequency. So here we are saying that the median is the n plus 1 over 2 ith item. So because there are 180 observations, in other words, we have 180 students. 180 students. The middle student will occupy position number 90.5 as 180 plus 1 over 2, which is that. Now, where does position 190.5 lie? So 90.5 lies between here. Just look at this. Sorry, 90.5 is somewhere between here. Why are we saying so? Because this cumulative frequency is ranging between 60 to 110. So 90.5 is in between. And where does it fall? It falls in this cumulative frequency. And that cumulative frequency has a corresponding value of max that is 35. So you can see this median has a corresponding max of 35. And that's how we get it, as simple as that. Now, suppose it was continuous data. Remember, this is discrete, so it is discrete. What about if it is continuous?